Download this code from codegive.com, link in the description below. Deep dive into scipy image erosion and the segmentation fault, bug Segfault with binary erosion issue 22533. This tutorial will provide a detailed understanding of the segmentation fault issue encountered during binary erosion in scipy, specifically related to issue 22533, https://github.com/scipy/issues/22533, on the scipy GitHub repository. We'll cover the following. 1. Fundamentals of binary image erosion *, what it is, how it works, and its applications in image processing. 2. Scipy's binary_erosion function *, understanding its parameters, behavior, and underlying implementation, at a high level. 3. The segmentation fault issue, 22533. Details of the bug, its trigger conditions, potential causes, and the discussion surrounding it in the GitHub issue. 4. Code examples * demonstrating the bug, including the specific scenario that triggers the segmentation fault. 5. Workarounds and solutions * discussing potential fixes, alternative approaches, and how to mitigate the issue. 6. Debugging techniques * tools and strategies for diagnosing segmentation faults in scipy, and Python in general. 7. Contributing to scipy * how to report bugs, contribute fixes, and participate in the scipy community. 1. Fundamentals of binary image erosion. Binary image * an image where each pixel is either 0 or 1, black or white, typically representing foreground and background. Binary images are commonly used after thresholding grayscale images or for representing shapes and structures. Erosion * a morphological operation in image processing that shrinks bright regions, foreground, and expands dark regions, background, in a binary image. It's used to remove small details, smooth edges, separate connected objects, and reduce noise. Structuring element, kernel, a small binary image, matrix, that defines the neighborhood around a pixel used for the erosion operation. It determines which pixels are considered part of the foreground for the erosion. Common structuring elements are squares, disks, and crosses. How erosion works *. For each pixel in the input binary image, 1. Overlay *. The structuring element is placed on top of the input image, centered at the current pixel. 2. Match * the pixel value in the output image is set to 1, foreground, only if all pixels in the input image that correspond to 1s in the structuring element are also 1s. Otherwise, the output pixel is set to 0, background. 3. Iteration *. This process is repeated for every pixel in the input image. In essence, erosion removes foreground pixels from the boundary of objects, effectively shrinking them. The size and shape of the structuring element determine the extent of the erosion. Applications of erosion *. Noise reduction * erosion can remove small, isolated pixels or regions of noise. Object separation * it can break connections between weakly joined objects. Feature extraction * it can be used as a pre-processing step for shape analysis and object recognition. Image segmentation * erosion can refine segmented regions. Edge detection * erosion followed by dilation, another morphological operation, can be used for edge detection. 2. Scipy's binary_erosion function. Scipy's scipy.endimage.binary_erosion function provides a convenient way to perform binary erosion on number pi arrays, representing binary images. Key parameters of binary_erosion *. Input, a number pi array representing the binary image. Structure, a number pi array representing the structuring element, kernel. If none, a 3x3 structuring element of all ones is used. Asterisk output, optional, an array to store the eroded image directly. If none, a new array is created. Useful for memory efficiency. Asterisk border underscore value, the value used for elements outside the borders of the input array. Default is 0. Crucial for defining how the image edges are handled. Asterisk iterations, the number of times the erosion operation is applied. Applying erosion multiple times shrinks the foreground regions further. Asterisk mask, a binary mask. Only elements in the input array where the corresponding mask element is 1 are processed. Asterisk origin, the center of the structuring element relative to its shape. If none, the center is assumed to be the geometric center. Asterisk border underscore type, type of border handling. This is usually reflect or constant. Reflect is equivalent to taking the mirror image about the edge of the border. Constant will pad the array with a constant value given in the border underscore value parameter. Asterisk vol, the value to fill past edges of input if border underscore type is constant. Asterisk in place, whether to modify the input array in place, if an output array is not provided. Using in place equals true can lead to unpredictable behavior and is generally discouraged. Asterisk number underscore threads, number of threads to use for parallel processing. Underlying implementation, high level. Scipy's binary underscore erosion function is implemented in C for performance. It leverages the endimage module, which provides a generic framework for n-dimensional image processing. The core logic involves iterating through the input image, applying the structuring element, and updating the output array based on the erosion rule. Optimizations are employed to handle different data types, structuring element shapes, and border conditions efficiently. 3. The segmentation fault issue, 22533. Issue 22533 on the scipy GitHub repository describes a segmentation fault encountered when using scipy.endimage.binary underscore erosion under specific conditions. A segmentation fault, Segfault, occurs when a program tries to access memory it doesn't have permission to access, leading to a crash. Key characteristics of the bug, based on the GitHub issue and related reports. Asterisk trigger condition asterisk the segmentation fault appears to be triggered by a combination of asterisk a specific array shape, often relatively small images, example 256x256 or smaller. Asterisk a particular structuring element, kernel, size. Asterisk potentially specific data types, example np.uint8 or np.bool underscore. Asterisk the origin parameter of the binary underscore erosion function being explicitly set. Omitting the origin or using the default often avoids the issue. Asterisk a high number of iterations. Asterisk root cause, as suspected in the issue discussion. Asterisk the most likely cause, according to the GitHub issue, is an off by 1 error in the indexing or pointer arithmetic within the C implementation of binary underscore erosion. This error could lead to writing data beyond the allocated memory for the output array, causing the seg fault. Asterisk the interaction between the origin parameter, the structuring element size, and the boundary handling logic, example border underscore value, likely exacerbates the problem. Asterisk reproducibility asterisk the bug is not universally reproducible. It depends on the scipy version, the number pi version, the operating system, and the underlying hardware architecture. Why segmentation faults are troublesome asterisk. Asterisk abrupt termination asterisk they cause programs to crash unexpectedly without providing helpful error messages in Python. Asterisk difficult debugging. Asterisk the root cause is often buried deep within C code, making it challenging to pinpoint the exact location of the memory access violation. Asterisk data loss. Asterisk unsaved data can be lost when a program crashes due to a seg fault. 4. Code examples demonstrating the bug. The following code example is adapted from the GitHub issue and aims to reproduce the segmentation fault. Important asterisk this code may crash your Python interpreter if it triggers the bug on your system. Save your work before running it. Explanation of the code asterisk. 1 trigger underscore segfault, function asterisk encapsulates the code that attempts to trigger the seg fault. 2 image equals np.zeros, 256, 256, type equals np.uint8, asterisk creates a 256x256 binary image filled with zeros. Try changing the type to np.bool underscore as this has been reported to trigger the error. 3 image 120:130, 120:130 equals 1 asterisk creates a small foreground region, a square of ones, in the center of the image. 4 structure equals np.ones, 5, 5, type equals np.uint8, asterisk defines a 5x5 square structuring element. 5 endimage.binary underscore erosion, asterisk calls the binary underscore erosion function with specific parameters. Asterisk border underscore value equals 0, sets the value for pixels outside the image boundary to 0. Asterisk iterations equals 30, applies the erosion operation 30 times. Increasing the number of iterations is more likely to trigger the bug. Asterisk origin equals 0, this is the key parameter. Setting the origin explicitly seems to be necessary to trigger the seg fault. Try different values, example origin equals 1, origin equals -1. The default origin usually avoids the problem. Asterisk border underscore type equals constant, setting the border handling type. 6 print, erosion completed, asterisk this message is printed only if the erosion completes successfully without crashing. 7 error handling asterisk the try, except block attempts to catch general exceptions that might occur during the process and print them to the console. This helps in understanding the type of error, if not a seg fault. How to run the code and test for the bug asterisk. 1. Save the code asterisk save the code as a Python file, example erosion underscore segfault.py. 2. Run the code asterisk open a terminal or command prompt and run the script using Python erosion underscore segfault.py. 3. Observe the output asterisk. Asterisk segmentation fault, crash if the code crashes with a segmentation fault error, you've likely triggered the bug. Asterisk erosion completed. Message asterisk asterisk if the code runs without crashing and prints this message, the bug was not triggered on your system with those specific parameters. Asterisk other exception asterisk check the exception type printed to the console. Experimentation asterisk. Asterisk change type asterisk try different data types for the image and structuring element, example np.bool underscore, np.uint8, np.int32. np.bool underscore has been frequently cited in issue reports. Asterisk change structure size asterisk vary the size of the structuring element, example 3, 3, 7, 7. Asterisk change iterations asterisk adjust the number of iterations. Asterisk change origin asterisk experiment with different values for the origin parameter. This is the most important parameter to modify for triggering the bug. Asterisk remove origin asterisk remove the origin parameter completely. Asterisk scipy and numpy versions asterisk note the scipy and numpy versions you are using print, scipy underscore underscore version underscore underscore, and print, numpy underscore underscore version underscore underscore, and whether the bug is triggered or not. This information is crucial for debugging. Asterisk operating system and Python version. Asterisk note the operating system and Python version you are using. 5. Workarounds and solutions. Since the bug is related to memory access violations, the following workarounds might help. Asterisk avoid explicit origin. Asterisk the simplest workaround is to avoid explicitly setting the origin parameter. Let scipy use its default origin, which is the geometric center of the structuring element. This has been reported to prevent the segfault in many cases. Asterisk smaller structuring element. Asterisk using a smaller structuring element, example 3x3 instead of 5x5 or larger, can sometimes avoid the issue. Asterisk fewer iterations. Asterisk reducing the number of iterations might prevent the memory corruption that leads to the segfault. Asterisk padding the input image. Asterisk padding the input image with a border of zeros, or another appropriate value, can give the erosion operation more room to work with, potentially preventing out-of-bounds access. You can use np.pad for this. Asterisk alternative libraries. Asterisk consider using alternative image processing libraries like OpenCV, CV2, or scikit-image, skimage, which might have more robust implementations of binary erosion. However, be aware that the results may not be identical due to differences in implementation details. Asterisk rolling back scipy. Asterisk if you need to use a specific set of parameters that trigger the bug in your current scipy version, you could try rolling back to an older scipy version where the bug was not present. Use pip install scipy == version to install a specific version. Important asterisk rolling back to older versions might introduce other bugs or security vulnerabilities. Asterisk scipy nightly builds. Asterisk sometimes the bug is fixed in the nightly builds of scipy but not yet released in a stable version. Try installing the nightly version of scipy using pip install pre-scipy. Asterisk compiling from source. Asterisk compiling scipy from source might allow you to apply a patch or workaround directly to the C code, if a patch is available in the GitHub issue or elsewhere. 6. Debugging techniques. Debugging segmentation faults can be challenging, but here are some tools and strategies. Asterisk GDB, GNU Debugger, a powerful command line debugger for C/C++ code. You can attach GDB to the Python process and step through the C code within scipy to identify the exact line where the memory access violation occurs. Asterisk install GDB. Asterisk sudo apt-get install GDB, Linux, or brew install GDB, Mac OS. Asterisk run Python with GDB. Asterisk GDB Python. Asterisk set a breakpoint. Asterisk before running the code, set a breakpoint in the C code of binary_erosion. This requires knowledge of the scipy source code. Example break endimage /src/ni_binary.c123. Asterisk run the Python script. Asterisk within GDB, run your Python script using run_your_script.py. Asterisk step through the code. Asterisk use GDB commands like next, step, print to inspect variables and step through the execution. Asterisk valgrind, Linux only a memory debugging tool that can detect memory leaks and invalid memory accesses. Asterisk install valgrind. Asterisk sudo apt-get install valgrind. Asterisk run Python with valgrind. Asterisk valgrind leak check = full Python your_script.py. Asterisk analyze the output. Asterisk valgrind will report any memory errors it detects. Asterisk address sanitizer, ASAN, a memory error detector that can be integrated into compilers like GCC and Clang. It provides more precise error reporting than valgrind. Asterisk compile scipy with ASAN. Asterisk requires recompiling scipy from source with ASAN enabled. Asterisk run the Python script. Asterisk run your Python script as usual. Analyze the output ASAN will report any memory errors it detects. Python debugger, PDB. While PDB won't directly debug the C code, it can help you inspect the Python variables and data structures before the call to binary_erosion, allowing you to identify potential issues with the input data. Insert breakpoints. Use import PDB, pdb.set_trace, in your Python code to set breakpoints. Inspect variables. Use PDB commands like p_variable_name to print the values of variables. Logging. Add logging statements to your code to print the shapes, data types, and values of relevant variables at various points in the execution. This can help you narrow down the region of code where the error is occurring. Binary search. If you can reproduce the bug consistently, try a binary search approach to isolate the problematic parameter values. For example, if you suspect the iterations parameter is involved, try running the code with iterations equals iterations/2, iterations equals iterations *2, and so on, until you find the range of values that triggers the bug. 7. Contributing to scipy. If you encounter the segmentation fault and have gathered valuable information, example a minimal reproducible example, details about your system configuration, consider contributing to the scipy project. 1. Search existing issues * before reporting a new bug. Search the scipy GitHub issue tracker to see if the issue has already been reported. 2. Provide a minimal reproducible example *. The most important thing you can do is provide a small, self-contained code example that demonstrates the bug. This will help the scipy developers reproduce the issue and debug it effectively. 3. Include system information * include details about your operating system, Python version, NumPy version, scipy version, and any other relevant software or hardware configurations. 4. Describe your observations * explain what you have tried, what you have observed, and any patterns you have noticed. 5. Consider contributing a fix * if you are familiar with C/C++ and the scipy code base, you might be able to contribute a fix yourself. Follow the scipy contribution guidelines, available on the scipy website and GitHub repository. Create a pull request with your proposed fix. Reporting a bug *. Go to the scipy GitHub repository, https://github.com/scipy/scipy, https://github.com/scipy/scipy. Click on Issues. Click on New Issue. Fill out the issue form with the information described above. Conclusion. The segmentation fault issue in scipy.endimage.binary_erosion is a complex bug that can be difficult to diagnose and resolve. By understanding the fundamentals of binary erosion, the scipy implementation, the trigger conditions of the bug, and the available workarounds, you can increase your chances of avoiding the issue or contributing to its resolution. Remember to always save your work before running code that might trigger a segmentation fault. Good luck debugging.